All right, so today we're talking about chapter 10 or lesson 10.1, use properties of tangents. So chapter 10 is all about properties of circles, so it might be nice to have a little break. So here are some definitions. Number one, a circle is the set of all points that are equidistant from the center. I'm going to do my best to draw a nice circle with the center P. The notation for a circle like this would be circle P. Looks like OP, but whatever the center is, whatever that letter, that is how we name the circle. Radius is the distance from the center to a point on a circle, a segment whose endpoints are the center and the point on the circle. It sounded crazy when I said it out loud, but you guys know what a radius is, right? If I still have my circle P here, and then let's say this segment goes to Q, and then let's say this segment goes to R, right? So the radius would be PQ, it's a segment, and PR. The radius is the same length. Any segment from the center of the circle to the edge of the circle will be the same length. All right, number 3, congruent circles. Two circles with the same radius. Well, if I drew two circles, this one has a radius 7, so the other circle must also have a radius of 7 in order for it to be congruent. If you need to pause this video to write these definitions down, please do so now. All right, number 4, diameter, the distance across the circle through the center. That's the most important part. So here I have my circle, and please don't judge because you know how my circles are. Still has center P. Let's say here's my diameter, it goes through. Here is A. Here is B. Okay. The thing about naming a diameter, we only use the points on the outside of the circle. So I could say the diameter is segment BA or segment AB. It doesn't matter which way I go. We're not going to say the diameter is BPA because we only use 3 letters to name an angle. Okay, so we do not use 3 letters to name the diameter. Only the 2 points on the outside of the circle. As long as that line goes through the center, it is a diameter. All right, a chord is a segment whose endpoints are points on the circle, but does not pass through the center. Okay, so it's like a segment, like here's my circle, and then like here's my center P, and let's say this segment here, I change color. RS, that is a chord, okay? A chord, again, is named the same way, just the two letters. So RS, my pen does not like that color. Let's go back to orange. So we could say, RS, or we could say SR. That is naming the chord. All right, a secant is a line that intersects the circle at 2 points. So think about a secant like a chord, but it goes on forever in both directions. So if I have my circle P, and then let's say I have 2 other points. I have A and B on the circle. And I have this secant line that cuts through the circle but goes on forever. So it's very similar to a chord, only when we name it, you want to be sure that it is a line, right? A line have arrows on both ends. That is a secant. A secant is a line, a chord is a segment. That's the only difference between the two. Again, if you need to copy down these definitions, please pause the video and do so now. All right, tangent. I'm going to have my circle P. A tangent is a line that intersects a circle at exactly one point, okay? A tangent does not go into the circle. Here's my circle P. Now I have some point K. I'm going to do my best to make sure that it touches. I'll make another point on that line, okay? Okay, so right here, it just touches the circle. This is what makes it tangent, right here. So how I name a tangent, because it's a line, it has to have arrows on both sides, I can go KD, or I can say DK. Okay, but the line does not go into the circle. Tangent circles, coplanar circles that intersect at one point. So if you can think about two circles, almost looks like a butt there, but right here they intersect at one point. Those are tangent circles. Number 9, concentric is a coplanar circle with a common center. So it's almost like a circle within a circle. So if we have a circle and we have our center P, the concentric circle is going to have the same center. Okay? Those are concentric. All right, there's only a couple more, but if you need to pause to copy this down, please do so. And I would suggest drawing the pictures too. It's good to have a visual understanding of what we're talking about. All right, number 10, common tangent, a line or segment tangent to two coplanar circles. Well, we know what a coplanar circle is, right? It's like tangent circles. So let's draw that. Well, let's just pretend that it's perfect, okay? And their tangent right here, because it just touches that one point. And then here is my common tangent. Okay, that's a straight line. By the way, I don't know what just happened, but you have your tangent circles, and then your tangent, common tangent is a line, okay? That intersects that point, that both the circles intersect each other. Point of tangency is the point at which a tangent line intersects a circle. So we already know what that looks like. Here's my circle. Here is some point B. If I draw a line, my tangent line here, this is the point of tangency. B is the point of tangency. All right, well, that'll do it with our definitions. Again, if you need to pause and copy this down, please do so now. Otherwise, let's look at some examples. Oh, well, let's first investigate some theorems. I apologize. So in Theorem 10.1, if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Okay, so let's draw a picture. First off, we have circle Q. That means there is a circle with a center named Q. Okay, then it says line M is tangent to circle Q at P if and only if M is perpendicular to QP. Okay, so we're gonna make this happen. Here's my point P. Okay. These guys are perpendicular to this line. This is my line L. I'll use fancy cursive for that L, okay? So now, and it says line M. Just kidding, why did I write L? So that is line M, which is perpendicular to the radius QP. Perfect. So I guess the most important part is that tangent line and that radius make a 90-degree angle. So that is really important. Now, theorem 10.2, tangent segments from a common external point are congruent. All right, so let's say I have all right, we're going to start with our circle P. And then it says SR and ST are tangent, okay? So there's going to be some point S out here. I'm going to change the colors a little bit. So there'll be some point S right here. Hopefully I didn't mess this up. And if this line is tangent, I'm going to use the cheater line because I'm afraid my lines are just not going so beautifully today. Oh. What we're going to do, oh boy. Yeah, well that's not going so beautifully either. Let's try again. Okay, so what I think I need to do is I need to move my point S because I really need that to be where they intersect. This is my point S. This would be my point T. This would be my point R. So what I'm saying is if there's some point outside of the circle that two lines come through that point and touch the circle, the length of those two lines are the same. They are congruent. Okay? So RS is congruent to TS. You could say TS or ST and SR, it doesn't matter, but those two segments between the points are congruent. All right, so now we have some practice problems, okay? So first off, we need to name this circle. That's what this means, number one. This is circle, look for the center, C. So we say circle C, okay? Number two says radius. We're going to identify all the radii. I guess that's a plural for radius. So ICCE, that's a radius. ICCF, that's a radius. And then I also see CG. Okay, those are the radii. Now the diameter, there's only one diameter. Remember, that is the line that cuts through the circle, through the center of the circle. So it would be FG would be the diameter. All right, we're going to name a chord here. There is a chord. Remember, a chord is not a line. It's simply a segment that does not cut through the center. So chord would be FB. A secant is like a chord, only it has arrows on both ends. So it is a line. So secant, HI. And then we have tangent, okay? Remember, tangent that touches the outside of the circle. So I have a tangent AD, where the point of tangency with AD is point G. That is the point where it touches. But I don't use that to name it, okay? AD. All right, now we're going to look at this. So it says, tell whether EF is tangent to the circle. Explain your reasoning. I want to know, is this line tangent to the circle? Because if it is tangent to the circle, then what happens with the radius, it makes a 90-degree angle. So how would I determine if this is true? I'm going to use the Pythagorean theorem, and I'm going to plug in all my numbers. I'm going to say, is 61 squared equal to 11 squared plus 60 squared? 61 squared is 3,721. 11 squared is 121. 60 squared is 3,600. When I add these two together, I get 31 21, which is what I have on the left side. So that is true. So yes, EF is tangent to the circle because, that's going to be my BC, because EF is perpendicular to DE. Okay? That's why. So when I say explain, that's what I'm looking for. When I say show your work, this is what I'm looking for. Okay, it's not that much, it's not that tough. I know you can do it. All right, let's look. We got 2 more examples. Oh, well, no, maybe we have 4 more examples. Let's check it out. Get my board to work. Come on, board. Okay, so here we go. So I want you to be really careful because do you see from the circle to the A, it says it's 4, but that is not what is here, right? This is just the radius. So often people think, oh, AC is 4, but that is not true because C to the edge of the circle is still 6, just like this radius here, okay? So now it makes the length of CA 10. Okay, so we need to determine, is AB tangent to the circle? Because we want to find out, is this perpendicular? Is this a right triangle? Okay, so we'll have 10 squared equals 6 squared plus 8 squared. I have 100. Oh, 36. I didn't write that. Nope, don't do that. Plus 64, 100 equals 100. So yes, AB is tangent to the circle because AB is perpendicular to BC. Boom, done. Not so bad. I know you guys can do the Pythagorean theorem. Just be really careful about this part, okay? Remember, any segment from the center of circle to the edge of the circle is the radius, and all the radius are the same length. So here in example 9, we have a very similar example, right? I want to know, is AC tangent to the circle? Do I have a right angle here? I don't know. Don't forget about the radius, right? The radius here is 10, so that means this part here is 10. Okay, so that makes the whole length of BC 25. Let's plug in our numbers. Right, 25 squared, is it equal to 10 squared plus 16 squared? 25 squared is 625. 10 squared is 100. All right, and 16 squared is 252, right? 256, please forgive me, I'm so sorry. And then when I combine these sides together, I get 356. That is not equal to 625. So, no. AC is not tangent to the circle because AC is not perpendicular to AB. Okay, so don't assume they're all going to work out because this one clearly was not. All right, so pretty much do the Pythagorean theorem. Don't forget to notice the radius, okay? Now, let's look at these two other lovely little circles here, okay? So this is like Theorem 10.2. We are talking about, they have the same length here. If there's some point out here that two segments come and touch the same circle, then we know that these are congruent. So we say 6x plus 12 is equal to 10x plus 4. All right, if I subtract 10x, that gives me negative 4x plus 12 is equal to 4. Subtract 12, negative 4x is equal to negative 8. Divide by negative 4, x is equal to 2. If I plug that back in here, 6 times 2 plus 12 is 24. 10 times 2 plus 4 is 24. They are the same. Yippee-doo. Okay. That was easy, right? Now number 11's a little different, but don't worry. It'll be fine. It's the same concept, okay? Just our numbers are a little funky. Okay, so there's this point A out here in space, and there's two lines that touch the same circle. That makes those lines congruent. So I have x squared plus 24 is equal to 49. Subtract 24, and I have x squared is equal to 25. Right? How do we unsquare something? We take the square root. Then I get x is equal to plus or minus 5, but honestly, the only thing that makes sense is positive 5. Because if we plug in negative 5, actually, if we plug in negative 5 here, we'll have the same thing. So really, this is true. Okay, because when I square 5 or negative 5, I'm going to get 25, and I add that to 24, I get 49. Okay, so they are congruent. All right, cool. Please let me know if you have any questions. I'm here for you up until like 11 o'clock at night, and then that's it. I got to go to bed, people. All right, have an awesome day, and here is your homework. Assignment number 50, page 645 to 646, number 3 to 10, and 18 to 26. All right, bye.